labor example. Okay, so let me see. Yeah, let me cover a few more slides, and then we will take a short break. In context learning with few shot inference. Right. So we have this example. The problem is that answer the question using the format shown in the context. So this is what we call instruction as part of the prompt. And then we have a context. Context are essentially some examples that you can include as a part of the prompt. In this case, we have a few examples. Who won the baseball World Series in 2022? So we gave the model this answer. Houston Astros won the World Series in 2022. They defeated Philadelphia Phillies. And similarly, we give another example. Who won the baseball World Series in 2021? The Atlanta Braves won the World Series 2021. They defeated Houston Astros, and so on. We can give a few examples. And then after that, we can have the question, who won baseball series in 2016? So compared to what you saw very early in that example, the model was very chatty. Here, if we give the model such series of contexts or examples, the models should be able to learn that the output, the completion that we expect will be something like this. So after that, the completion you will very likely to see is that the Chicago Cubs won the World Series in 2016. They defeated Cleveland Indians. These examples are included as a part of your input prompt, as part of the context, and these are called shots. So if you don't have any of the example, it's basically zero shot. So you basically don't give the model any new information. You just whatever the model is trained on, so the model will spit out the output as the completion. Yeah.
How do these models know when to stop?
So sometimes they don't stop. You will see that some models, they're very chatty, they spit out a lot of information. But with these kind of few shots learning, they will know, okay, this is the stop point that they will basically use that information. You just give it to the model. They will be able to tell that this is a good point to stop. We actually let you run a few examples or provided on the exercise. You will see that some of the model, even after the fine-tuning phase, it's not really stopping unless you have a max token that will force it to not spit out more tokens beyond that point. Yeah, but that was a very good question. Also, models can learn from example to generate the desired completion in the desired format. The prompt structure depends on the context window. Basically, the number of tokens the model can take as an input when generating a completion. If you keep asking questions, keep having the conversation, so your chat window will grow, continuously. But if the number of tokens in the context window exceeds the maximal input the context window of the model is trained for, then the model will just ask you to start a new chat window. That's basically the limit of the tokens that it can take as an input when generating completion. We have to say that this in-context learning does not modify the model, which has billions of parameters. There's other way, like we show as example and also discuss in later classes is the fine tuning, where we do change the parameters of the model. But using this in context learning, giving it more examples does not really change that model itself. It just learns on the fly for the duration of that context. Zero shot is where we don't have these examples, and one shot is give you, you basically provide one example of that. Zero shot often is used to evaluate the model's ability to perform a task that hasn't been explicitly trained on. All right, so it sounds very good, but there are cases that this in-context learning can go wrong. This is another example. So we have instruction like this: classify the sentiment of the review using the format shown in the context. Now we want to pay attention to these three examples. First one, Wrigley Field is a fun stadium to watch a baseball game on a day with a clear blue sky. So if you don't, if we don't show you this, you can tell that sentiment-wise, this is a pretty positive sentiment, right? It's happy because you're talking about, a clear blue sky. It's fun stadium, so it's a positive sentiment. But we purposely set it the opposite, so we say this is a negative sentiment. Second example, the hungry seagulls during the ninth innings of a home Cubs game are very aggressive and annoying. So these two words definitely not very welcoming words. So if you were asked to tell the sentiment of the sentence, you're probably going to say it's negative. But here we purposely set it as a positive. So the third one is the same. So we basically reverse that. So we gave this model some shots, but these are purposely wrong sentiments that a normal person would classify these sentences. If the model are given these, chances are if you're asking this new sentence, Harry Caray was the best Cubs sport announcer of all time. This, to me, is a positive sentiment, and you expect that opposite is a positive, but because you gave a few of these wrong examples to learn, so there's a chance that this sentence will be classified as a negative sentiment. So this is where some information, if you give as the context that are not true or not truthful for some reason, and you will have likely a wrong completion. But this same example, I encourage you to try in different models. Actually try this in the DeepSeek model, and it actually gave the correct completion, which is very impressive. I encourage you to try it on different models to see whether these models can learn or actually, learn temporarily on the fly this information, or is it the case that the model itself has already such knowledge that these on the fly information will not impact the final result. So that's something that, yeah.
So what is the gone wrong part of this? Is it?
So the gone wrong part is that, see, these given examples are not truthful examples.
They're like opinion based?
Yeah, in this case, they're opinion based, but just as a common sense, if you are asked this question to tell the sentiment of this sentence, you probably give it positive, right? Because I see fun stadium and a clear blue sky. But we gave this example as saying it's a negative sentiment, so which is incorrect compared to common sense. Yeah.
Okay, sorry.
Yeah, so these three examples are all the same flavor in a sense that the sentiment we gave the model is actually not truthful. if I just tell from, my personal view. Does it make sense?
Yeah, I'm sorry, I
Yeah.
thought positive and negative meant like, if like, it's true or false. Not
Oh,
like,
no,
not
like,
like if it's
yeah,
the tone of it.
yeah, the tone of it, yeah.
Yeah.
Yeah. All right, so there are some best practices, so that you can, take advantage of these models without needing, substantial programming or fine tuning. So let's say if the model does not generate the desired result, try one shot or few shot inference. Basically, give the model some examples, more information that you can learn on the fly, to give you the proper completion, especially if you desire a certain output format. And you need to provide a consistent, appropriate mix of prompt completion examples. So that's basically what we show in the earlier in context learning gone wrong. That's where we actually give inconsistent prompt completion examples. Those were all untruthful, incorrect ones. Also, we can limit the prompt length based on the context window of the model. If none of these work, you probably need to consider fine tuning or retrieval augmented generation. So those are the things we'll talk about later in this course. So that's where we need to do some programming using fine tuning methods or RAG framework to really change the behavior of the model to get you a better output. Other best practices, be clear, concise, use instructions, and avoid negative formulation. So say summarize in 5 sentences or less, instead of saying in no more than 5 sentences. Because, from natural language perspective, these two kind of equivalent, but since models are breaking down these into tokens, so these some models may not respond to these tokens if you only see 5 in this case.